In this question number 1, we have given this information. So there is a car which has a mass of 1150 kg. It is moving up, okay, and the angle of the hill on which it is moving up is 1.2 degrees to the horizontal. So this is horizontal. The resistance to the motion is 975 Newton. That means if it is moving up, the resistance is 975 Newtons. And this 975 Newtons, this includes air resistance plus friction. Alright, what is next? They are giving that the engine has this power. So power of engine is 35 kilowatt, that means 35,000 watt. We can't use kilowatt, okay? We have to use watts, so kilo will be interpreted as 1000. Alright, the velocity or speed of the car is 16 meters per second. Alright, and they're asking us to find acceleration. So what will we do? We'll find first what is the applied force by car's engine forward. Please remember that the power always belongs to engine, nowhere else, because engine is the one that is pulling this car, and that's why this will interpret into applied force. Okay, we know that the power is force times speed, and this force in case of this power will be applied force. So we can find that applied force is power divided by speed. Power is 35,000 and speed is 16 meters per second. Okay, this will be equal to something. I will take care of that later, but I can write it here. 35,000 divided by 16 Newton is the force which is being applied by the engine. So now this is the resistance, this is the effort. Is there any other force? Yes, there is a force which is a natural force by the weight of the car. The weight of the car is 1150 times 10 newtons, right? Mg, that is the weight of the car. So its component in this direction will be one more resistance to this force applied by the engine. So that will be 11500 sine 1.2 degrees. The one in this direction is always cos 1150 cos 1.2 degrees, and in this direction it is always sine. So we will not take care of the vertical component or y component of the weight. Why? Because they have already given us the combined resistance, which includes friction. For that we need this force in y direction. So we will not take care of this. So our everything is ready now. We can find acceleration. Now F net is always equal to mass times acceleration. Alright, and in this case, what is the applied force? 35,000 over 16. This is the applied force, but there are two forces which are in opposite direction, so we will subtract those two forces. Minus 11,500 sine 1.2 degrees. So MA is equal to, when I put this whole thing in my calculator, I get 971.662 newtons. Alright, and now we want to find acceleration. So acceleration will be this 971.66 divided by mass, and mass is 1150. So if 971.66 divided by 1150, it will give us 0.8449. So I can write this as 0.845 meters per second square.